All right, this is lesson 16.3 where we're talking about the quotient of powers property. It starts on page 724 if you're following along in your math book. And if you'll recall the last lesson, one of the properties was the product of powers. So when we're multiplying powers with the same base, we add the exponents. Well, here we're dividing powers with the same base. So we subtract their exponents. And if you see, the numbers that they give us are, for the key idea, is 4 to the 5th power over 4 to the 2nd power. And they show the subtraction, but really what this means on the top of the vinculum or fraction bar, for those of you that want to use such a 6th grade term, fraction bar, 4 to the 5th power means 4 times 4 times 4 times 4 times 4, and 4 to the 2nd power is 4 times 4. And if we simplify before we multiply here, 4 cancels with a 4, 4 cancels with a 4, and I'm left with just 3 4s on the top, which is 4 to the 3rd power, over 1, which is just 4 to the 3rd power. We could have gotten that just from subtracting these two to get 4 to the 3rd power. Okay, so this is why it works out. But if you can remember just to subtract those two. Now, to tell you the truth, all of these exponent properties, I usually have to look at something like this and say, okay, what's actually going on here? Oh, yes, this. Oh, yes, this is what happens. Oh, now I got it. Okay, so I just work through them every time. If you want to memorize the properties, that works out well. And I will continue to put them up here as we go through the problems. So now if we look at example 1, dividing powers with the same base. So here we have 2 to the 6th power, 2 to the 4th power. Obviously, 4 of these from down here cancel 4 of these from up here. Or you could just say we subtract these two and get 2 to the 2nd power. Here, it's just another thing to a power, just a base, okay? It's an integer, so it's a negative. Don't freak out. It's still, we have 6 more of these negative 7s on top, so it's negative 7 to the 6th power. In here, they slip right in just to do a variable, which could be anything, as long as h is not 0. So it's got one little exception here. H cannot be 0, because then we would have 0 on the bottom, and you can never have just a 0 on the bottom of the fraction bar, because that means divided by 0, which is not okay. So here we have h to the 7th over h to the 6th. They cancel each other out, and you're left with just h to the 1st, which is just h. And remember, h cannot be 0. So now they give us these on your own problems. And for on your own number 1, we have 9 to the 7th over 9 to the 4th, and that is 9 to the 3rd, because you just subtract those two. For number 2, 4.2, I'm going to circle this so it doesn't look like a weird number there, 4.2 to the 6th power over 4.2 to the 5th power. So when those cancel out, you're left with just one of those 4.2s on the top. You can put a 1 there, but it's not needed, just 4.2. Number 3, negative 8. Now these parentheses are not optional, because when we're raising a negative and we want it to be a negative to a power, we need those parentheses to keep the negative snug in with our number there. Negative 8 on the bottom with a 4. And when those cancel out, you'll be left with 4 negative 8's as factors up on top still. And then there's one more, and instead of using a whole nother line, I'm squeezing it over here. Do as I say, not as I do. You should not do this. X to the 8th power over x to the 3rd power, and when they cancel out, you are left with 5 x's multiplied together on top, x to the 5th. Excelente. See what I did there with the whole x thing? Okay, whatever. Example 2, simplifying the expression. So now we're putting a couple of these rules together to multiply these two powers with the same base. You would add these two. So 3 to the 4th times 3 to the 2nd, remember, would be 3 to the 6th. And then that you would have 3 to the 6th power over that 3 to the 3rd. And now you can subtract those two and get 3 to the 3rd. Now, if you wanted to, you could have simplified these first and then gotten 3 to the 1st right here. And then you've got 3 to the 1st times 3 to the 2nd. And you'd still get 3 to the 3rd power. But order of operations does tell us to simplify the numerator and simplify the denominator before we start doing anything between the two. So do simplify the top there, and the bottom's already simplified. And then you can subtract the exponents. A couple more on your owns for us. Is it on your own time? It's not yet. Oh, we have example 3. My bad. Simplifying expression again. And here, notice we have a to the 10th over a to the 6th times a to the 7th over a to the 4th. Here, they simplified each fraction first because of that multiplication right there. So we actually have one fraction here, one fraction here. So they did the 10 minus 6 to get a to the 4th, and 7 minus 3 to get a to the 3rd, and then they added those exponents because we're multiplying two powers with the same base. A to the 4th times a to the 3rd is a to the 7th. Now, another thing we could have done when you're multiplying these is just make that just a humongo vinculum right there. We could have combined these first, combined these second, and then do the subtraction afterwards. And now we're on to a couple more on your owns. Number 5 is 2 to the 15th for the numerator, 2 to the 3rd times 2 to the 5th for the denominator. So the first thing we should do is simplify this denominator. We're multiplying those, so it would be 2 to the 8th, adding those powers, and then 2 to the 15th on top. And now we subtract, and we get 2 to the 7th left on top, which would just be over 1, which we just leave like that. Number 6. D to the 5th over D times D to the 9th over D to the 8th. Well, the first thing we could do is just make that a big vinculum, add these two, and then subtract. However, I'm thinking what they want us to do is do these in part. So D to the 5th over D is just D to the 4th times D to the 9th over D to the 8th is just D. And then D to the 4th times D, or D to the 1st, would be D to the 5th. One more, and that is number 7. 5 to the 9th over 5 to the 4th times 5 to the 5th over 5 squared. This is going to be 5 to the 5th here. And this is going to be 5 cubed, or 5 to the 3rd here. And that gives us 5 to the 8th power. Excellent. So 2 to the 7th, D to the 5th, yes. All right, so now you can head on over and do journal page 378 and then do the questions. All right, have a great day.